Hi, I'm Erik Linask. I'm coming to you from Interop in Las Vegas, and I'm here with Paul Skoog from Symmetricom. Welcome, Paul.
Thank you. Glad to be here.
Now, you just described Symmetricom to me as the world's largest clock maker. What do you mean by that?
Well, Symmetricom manufactures clocks all the way from like miniature atomic clocks to hydrogen masers, which are used for time standards for countries around the world. We sell to telecommunications, wireline systems, wireless, and government, military, aerospace systems. Timing is involved in a lot of different areas to make things operate smoothly and properly. Here at Networld Interop, we're pretty much featuring what's called a network time server. This is going to be a clock that sits on your network and serves NTP packets, is essentially what we're talking about here at this show.
And now, why does somebody need a clock from Symmetricom for the network as opposed to the various clocks that are already existing on their servers and routers and other devices?
That's a great question. We get asked that all the time. Networks are full of clocks, right? Every device, servers, workstations, routers, everything's got a clock in it, okay? And generally speaking, they're usually all a little different. And so consequently, when you're running a network with all these clocks drifting at different rates, and some are right and some are wrong, it creates a problem for the IT guy who, on his servers that are serving files at a high rate, he's maintaining log files. These log files are being aggregated, through a syslog process. And the problem is when the time is different on all these devices, the timestamps are going to be different, and when they get aggregated, they don't line up right. And that can be a real problem for our customers that are running networks, 10 servers or more. It's usually a problem when they have a problem. They want to go in, they want to use their network management software to do some forensics. They might be in a big hurry, and they find that the data is not lining up right. So they first have to solve the data alignment due to the timestamps, and then proceed to solve their problem. So it can be a real headache for the IT guy if those timestamps aren't correct, server to server. So,
So how do I get your clock into my network?
Okay. We have people coming by the booth talking, hey, that's a great looking product, a good looking clock, I get time free from the internet, why should I buy your product? Okay. And it's a good question. It's a valid one because you get free time off the internet. So the value proposition of a clock is accuracy, reliability, security, and easy use. Essentially, instead of relying on a clock that's at a distant location, it's out of your control, you don't know if it's available, you don't know if the time is right, the network between you and there is non-deterministic, you had to open your firewall up. A lot of customers realize that they want to take control of that time, and so they'll buy our product, which is the GPS reference network time server. It's very accurate, goes inside the firewall. It's a much more secure source of time. We actually have some white papers on people getting time from the internet, and they were spoofed. And the poor IT guy says, he came in that day and he didn't make many meetings because of the disaster caused by the wrong time served from an internet time source. Nonetheless, they're easy to set up, and we also strive to make them so easy to use and reliable that you sort of forget you own it. Customers say we want it to be easy to install, we want to forget we own your product. And that's what we strive to do, and we had customers literally tell us, we forgot we owned your product.
How are you able to keep more accurate time than some of these other devices out there?
That's a good question. So we use the GPS satellite system. The GPS satellite system is continuously, there's about 31 satellites in the constellation. They're moving. Each one has 3 atomic clocks on board. So we put an antenna up. It's either on the roof or it's in the window. The antenna is about the size of a coffee cup. And you connect it to our device, our server. It's a one-use server. It syncs up automatically, no charge, of course. Use GPS is free. So the clock is now accurate to about 50 nanoseconds to UTC. So it's an extremely accurate clock, okay? And then the clock itself has multiple network ports. And one of them is used for management and time. And each port has its own IP address subnet mask. So it can appear as its own NTP server on the network, and so you can, subnet it out or have different physical networks, and one clock can serve all the time on the network, and it just makes it real easy to deploy, and of course it's extremely accurate because it's using GPS as its source of time.
So who's deploying them?
Well, that's a fun question, actually. Okay, at least for us, in as much as you ask, well, who needs a clock like this, right? Maybe you think a bank because they're doing financial transactions. That's an obvious one, right?
Sure.
I mean, we synchronize the New York Stock Exchanges, and all the major banks all have our product. But at the same time, you get the U.S. Supreme Court showing up, various military bodies, and then you'll get a cruise line or a famous maker of chocolate, right? And what they all have in common is they're running an IT network that has 10 or more servers, and they have a network management system, and they have log files, and it needs to be accurate, and it becomes an issue for them. I remember one small case. The first time I ever asked that question, why do you need this? It was the maker of milk cartons. I asked him, you make milk cartons, what do you need a time server for, right? And he says, I've got a facility full of servers making log file entries, and it's an essential thing for an IT guy to have that information correct.
Do you work equally well in a distributed environment?
Absolutely. NTP has been around for some time, and it's a pretty robust protocol. And so when a customer comes along and says, well, I've got a data center in London, New York, and Tokyo, how are you going to help me here? Well, that's the beauty of GPS. The satellites orbiting the planet, you can put a time server in each data center. They will synchronize, of course, everything in that data center, and then you can peer those time servers together so that they monitor the time on each other. And if, for example, one of the GPS antennas gets disconnected, that time server will get its time from the other one. And in fact, actually, the best bit of advice I ever tell people when it comes to a distributed time network is always have your clients point to the time clients, point to at least 2 time servers, and never accept a large time offset. So the beauty of that is if one of the time servers goes away, you have an alternative, and if one of them is wildly wrong, you won't accept a big time offset. So,
excellent. We've been chatting here at Interop in Las Vegas with Paul Skoog from Symmetricom, who can help you with all of your network clock needs. Thanks, Paul.
Great. Thanks, Erik.